This is section 2.5. This is part 3, which also includes 2.2 and 9.1. We've already discussed how to do a scatter plot. We've discussed line of best fit, and we've discussed how to find the correlation coefficient. Now we're actually going to find the equation of that line of best fit, and we're going to use that equation and that line to predict some y values using that regression equation. Okay, so in this section here, a regression line is a line created for which best fits the data. The regression equation is the equation of the regression line for an independent variable x and a dependent variable y. Your equation is y equals mx plus b, and what you're going to do is you're going to find out that your m or your a value is going to be substituted in from your calculator, and then your b is the y-intercept, which is also going to be substituted. Again, y is the predicted value for any given x, m is the slope, b is the y-intercept, and what you're going to do is you're going to use your graphing calculator with your linear regression to figure out all this data. Okay. Now, this is your calculator sequence for how to find the regression equation. Okay, we've talked about this again, gave you an example of this, and then I'll let you read through this and be able to figure that out with your calculator. And now let's take a look at some examples. Okay, it says here, a teacher wonders if there's a correlation between the number of days a student was absent and that student's semester test grades. He collected data for the following 5 students. So, if you have your calculator with you, you plug in these five data points, and you're going to figure out what is the correlation value of the given data. And when you figure that out, you do your linear regression on your calculator, you find out that R has a value of negative 0.9366.
Cassandra.
Now, we did this in our previous notes where we figured out how to find the correlation coefficient, and that correlation coefficient is able to tell us the strength and direction. In this case, it's negative 0.933, so this is a strong, and it's going in the negative direction, correlation. It's a strong negative correlation. Now, as you look on your calculator, when you go through to calculate this, once you've put the stat, information in your stat part, and you've done your linear regression, you'll notice that you have some values on here, and in this case the a value is important. The a value is negative 1.98. The b value is 90.76, and you'll notice that again on your calculator your equation is in there as y equals ax plus b. Well, a just stands for the slope. Okay, so the equation of our line of best fit here is y equals negative 1.98x plus 90.76. Okay? So now we're able to find that equation, and now we want to do a little predicting. So it says use the equation to predict the grade of a student who has been absent for 13 days. Okay? So this value here is your x value. So you're going to substitute this in for x into your equation that you found. So y equals negative 1.98 times 13 plus 90.76. And when you calculate that out, 1.98 times 13, you add that to 90.76, you get a y value of 65.02, which means that the semester grade percentage for 13 days being absent would be somewhere around 65%. Okay, let's go through this final example now. Again, first thing you would do is you would enter in all this data into your calculator, go through your stat button, and calculate a linear regression, and you will find out that the R value, or the correlation coefficient for this data, is negative 0.9044. Okay, and again, this is a strong negative correlation. Okay, it's a strong negative correlation. It's between that value of 0.75 and 0.99. It's in the negative direction. Okay, And if you will continue with on that slide on your calculator, you would find out that your A value for the regression in this case is negative 7.91, and your B value or your y-intercept is 98.05. So your equation of the regression line is y equals negative 7.91x plus 98.05. And it wants to use this equation now to predict the test score when someone spends 6 hours. Again, this amount is going to go in for x. So when you substitute this in, times 98, or negative 7.91 times 6 plus 98.05, you end up getting a y value of 50.59. Okay, so when you study 6 hours, when you spend 6 hours studying, you would end up with around a test score of 50.6, 50.59. Okay, the next question asks, use this equation to predict the test score when someone spends 14 hours. Again, we're going to use the same equation. And we're going to substitute 14 now in for x. And now when you substitute that value in and you actually calculate this, the y value comes out as negative 12.69. So you spend 14 hours studying, you get a negative 12.7 or 12.69 grade or percentage. Does this answer make sense? Why or why not? Well, this answer right here doesn't make any sense. Here's why. Can't have a negative test score. It's not possible. So it's some of these questions that you're going to be asked, you're going to have to use some common sense and some logic and see, okay, is this really make sense? Can this be possible? Okay. So this concludes part 3 of the first section in the stats unit 2.2 and 9.1. Don't forget to complete your WSQ.